So Albert Einstein once imagined himself flying on a beam of light, and that thought experiment led him to figure out the theory of relativity. Essentially, Stephen Hawking is working on a similar plan where they're going to send a tiny spaceship to the nearest star to us, Earthlings, by using a tiny light sail and a light beam. And that's it, a tiny light sail and a light beam. Astrophysicist Stephen Hawking and businessman Yuri Milner recently announced a $100 million plan called the Breakthru Starshot project. And the Breakthru Starshot project is going to send 1,000 miniature spacecrafts called nanocrafts, which are no bigger than an Android smartphone, to the Alpha Centauri solar system. The Alpha Centauri Milner is the one that's putting up the $100 million to start Breakthru Starshot, but it might cost about $5 to $10 billion. Now, they're trying to send it to the Alpha Centauri solar system. And the Alpha Centauri solar system, the stars that are closest to America, is actually 4.37 light years away. 4.37 light years away. Light travels at 186,000 miles per second. So 4.37 light years away is approximately 25 trillion miles away. 25 trillion miles away. So the Alpha Centauri solar system is about 25 trillion miles away. Okay, so the Alpha Centauri solar system has 3 suns in its. The Alpha Centauri solar system actually has 3 suns in its solar system. It has Alpha Centauri A, Beta Centauri B, and a small and faint red dwarf star, Alpha Centauri C, which is better known as Proxima Centauri, which may be gravitationally bound to Alpha Centauri A and Beta Centauri B. So there's 3 suns, okay? There's 3 suns in its solar system. It's the one that's closest to us, and we can learn a lot from an up-and-close and personal visit of the exoplanets of the Alpha Centauri solar system. So how the Breakthru Starshot project will work is like this. A rocket will deliver a mothership carrying 1,000 or so small nanocraft probes into space. Once in orbit, the nanocraft probes would unfurl a lightweight solar sail and then propelled and powered. Once the mothership carries 1,000 or so nanocraft probes into space, then it would unfurl a lightweight solar sail and then propelled and powered by a powerful laser beam from Earth, set off one by one like a flock of migrating butterflies across the universe. Within 2 minutes, or like a Twister, right? Remember the movie Twister, when they, had to get all those little sensors go into the tornado? So, right, you send the mothership out, then there's 1,000 of these tiny, small, gram-sized nanocraft probes would just be, going through the universe. Essentially, instead of sending one expensive spaceship through space, they're going to try to do a lot of it's not that cheap, but kind of cheaper. So 1,000, if it ran into space debris, you still have more that are traveling out. So once in orbit, then the mothership is in orbit, and the 1,000 or so small nanocraft probes are released into space after they unfurl their lightweight solar sail. So a little sail, then a light beam goes onto the sail, and then it's going out, and it goes with that. Within 2 minutes, the probes would be more than 600,000 miles away from home, as far as the lasers could maintain a tight beam, and moving at 1/5 of the speed of light. The speed of light is 186,000 miles per second. It would still take 20 years for them to get to Alpha Centauri. Those that survived would zip past the star system, making measurements and beam pictures back to Earth via radio waves. Now, in Hawking's Briefer History of Time, published some years ago, Hawking mentioned that our most current technology, the Voyager technology, it would take us 10,000 years, or 30,000, or 40,000. I've heard lots of different numbers, but 10,000 years to reach the Alpha Centauri solar system if we were to use the technology today. So that means if we were to send without, using the technology today, a spacecraft, we wouldn't reach it until 12,016 AD. 10,000 years from now. But by using these tiny gram nanocrafts, gram-sized, gram-weighted nanocrafts, and light sails, solar sails, and then fueling the trajectories with a light beam, the nanocrafts can travel at 20% the speed of light. And that's 37,200 miles per second. And it would take about 20 years to reach the Alpha Centauri solar system. Then it would take the radio waves transmission of the pictures another 5 years. Approximately, with this Breakthru Starshot project, we're going to send out all these, gram, I figured it was a term like gram scale. So a gram scale nanocraft, using light sails and fueling their trajectories with a light beam, about 20 years to reach the Alpha Centauri solar system. And then it would take the radio waves transmission of the pictures another 5 years to return to Earth. That means we could see the fruits of the Breakthru Starshot project within our lifetimes if they launch the nanocrafts soon. But that might not happen for another 10 years or so. Okay, so just with that sort of timeline, that's 35 years. If I can live to be 70 years old, which is 6 years less than the average lifespan of an American male, then I'll be able to see if there's any planets or asteroids in the Alpha Centauri solar system. Light travels 186,000 miles per second, which is a good piece of information to know. The nanocrafts, the gram-scale nanocrafts, would also swing by targets in our own solar system. There might be microbes in the rings of Saturn, which is life. That's extraterrestrial life. It's aliens, right? A trip to Pluto at about 20% of light speed would take roughly 3 days instead of 9.5 years, which is the length of time it took NASA's New Horizons spacecraft to reach the demoted dwarf planet. 3 days instead of 9.5 years. So Breakthru Starshot aims to establish whether a gram-scale nanocraft on a solar sail, pushed by a light beam, can fly over 1,000 times faster than the Voyager technology that we've used in the past. Breakthru Starshot also aims to establish if there's any planets in the Alpha Centauri solar system. In 2012, researchers used an instrument called the High Accuracy Radial Velocity Planet Searcher to detect a planet around Alpha Centauri b. So there could be a planet around Alpha Centauri b. The instrument, which is part of the European Space Agency's La Silla Observatory in Chile, measured tiny wobbles in the star that suggested that a planet was orbiting it, likely just a bit bigger than Earth, and it orbits its star every 3.24 days. So this is fucking fascinating. This is exciting shit. Okay, not only can we reach in our own solar system and things that are around our solar system, but we're going to try to reach the nearest star to us. And that's remarkable, even though it's 25 trillion miles away. 25 trillion miles away. So, go science.